Okay, in section 3.9, we're going to look at what's referred to as differentials and linear approximation. Now, most of you are all familiar with the point slope formula. You've had to use that multiple times in here. Now, if you would say, well, my x value right here, I'm going to call A, and my, whoops, sorry, messed that up. Back it up. Okay, my x value, x sub 1, I'm going to call A. And my y value, y sub 1, I'm going to call f of A, meaning what I get for my y value when I plug A in. And then you know that your m is your slope, and our slope here in calc is our derivative. So if we go ahead and plug these three in right here, we end up getting this right here. Now, your linear approximation, you basically want to go ahead and get this by itself. Well, to get that by itself, you'd have to go ahead and add f of A to both sides. So we get y is equal to f of A plus our slope, f prime of A, times x minus 1. This is referred to as your linear approximation formula, which, when you're looking at the equation of your tangent line here, it's going to give us a pretty good estimate of what's going on in the actual value of our function if we are near that x coordinate of A. So if we're looking for our linear approximation of this function right here at this point, well, we need to know our derivative. So we'd have to figure out our derivative. We would need to know our A value, which is the x coordinate of our point, and we would need to know our y value. And that's really, if you didn't have the y coordinate, that's really what you get when you take your x and plug it into your function, and that in this case is 1. So we have to go ahead and do our derivative. Now remember that this is just to the 1/2 power. So you put the 1/2 in front, decrease your exponent by 1 to the negative 1/2, multiply it by the derivative of the inside, which is 1. In other words, we end up just getting this right here. Now, we're actually looking for our derivative at that particular x coordinate. Our x is 0, so we got to find our derivative at 0. So we take 0, plug it into our derivative, and we end up getting 1/2. So f of 0, or f of A, is the y coordinate of our point, which we know is 1. Here, this is our slope, which is our derivative at our particular x coordinate, which we just figured out to be 1/2. So we take and replace that green with 1/2. And in this case, our A value is 0, so we just have that in there. Well, the x minus 0 doesn't change anything, so I can just have this. This would be my linear approximation, which is a lot easier to work with if I needed to estimate some y values on this function when I was near x being 0.